Welcome to investigation 3.4. We're going to be solving quadratic equations in this investigation. So we are literally going to be able to find those roots and find what x is equal to. So that will be quite exciting. Let's do just that. So here's a quick question. If you know that the product between two numbers is 0, what can you say about those numbers? So if we were to say, for example, 3 times a number we don't know is equal to 0. What could we say about that number we don't know? Well, the only way that 3 can be equal to 0 would be if x were equal to 0. So we'd have to say that x was equal to 0. Well, what about this? What if we said f, a random number we don't know, times s were equal to 0? Two numbers we don't know. What could we say about those particular numbers? Same sort of thing. If f times s equals 0, that means either f has to equal 0 or s has to equal 0. Using this idea, we are going to solve for our roots. So we need to say, how can we solve this equation by factoring? How could we figure out what x is going to equal by factoring? So x squared plus 8x plus 12. Let's actually just factor this baby to start out with. 12 can either be 1 and 12, 1 times 12, 2 times 6, or 3 times 4. Looking at those, I also need to be able to see which ones are going to add or subtract to be 8. So 1 and 12 could add to be 13. 2 and 6 could add to be 8, 3 and 7 could add to be 7. So here are my prized possessions from this one. We have x plus 2 times x plus 6. That'll give me that expanded form of the equation. Now, we're going to take this whole idea a step further. We have this expression, x squared plus 10x plus 24. First, let's write this baby in factored form. We have x squared plus 10x plus 24. We're going to look at our factors of 24. We have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. What of these numbers will add or subtract to get me 10? Well, 1 and 24 gets me 25. 2 and 12 would get me 14. I should write an actual 4 instead of a blob. 14. 3 and 8 will get me 11, and 4 and 6 will get me 10. So here are my numbers that I'm going to use. So if we're going to write this in factored form, we'd say x out in front and x out in front, and we'd say plus 4 and plus 6. How can we use this factored form of the equation to solve for x in the following equation? We now have 0 is equal to x squared plus 10x plus 24. So essentially a number times another number is going to get me 0. I can say that because I can rewrite this equation as saying 0 is equal to x plus 4 times x plus 6. We know that this form of this equation is equivalent to this one. So we can substitute this form of the equation into this pink equation down here. So if 0 is equal to x plus 4 times x plus 6, we can essentially think, all right, what number right here would have to be in x's place to make this side equal to 0? Well, x would have to equal negative 4 for that to happen. Negative 4 plus 4 equals 0. And 0 times anything is going to be equal to 0. As well, we can look right here, x plus 6. Well, x could equal negative 6. If x equaled negative 6, we have negative 6 plus 6 equals 0, and 0 times anything would get me 0. So we just use the factored form of this equation to solve for x. Another way we could do it, so it's not just all in our head, is this. We could say 0 is equal to x plus 4, and actually use our properties of equality. Subtract 4 from each side, we get negative 4 is equal to x. We could also do the same thing for x plus 6. We could say 0 is equal to x plus 6. Properties of equality, I'm going to subtract 6 on both sides, so I get negative 6 is equal to x. Explain how the solutions of your equation in A2, this is A2 by the way, this is A1, A2 related to the graph of y is equal to x squared plus 10x plus 24. Just thinking, especially from the last couple of problems we've done in the last videos and that sort of thing, how are these solutions related to the equation of the graph? Well, I'm guessing that x equals negative 4 and x is equal to negative 6. I bet you these right here are zeros or roots or solutions, and therefore x-intercepts of our equation. We can be sure by actually doing or creating a graph for this. So let's do just that. Alright, so I've done a little work here to graph this equation. I have x squared plus 10x plus 24 is equal to y. I started out by finding my line of symmetry, negative b over 2a. So a was 1, b was negative, or b was 10, and we have it negative. So we end up getting negative 5. That's our line of symmetry. If we were to graph that, we would say there's a dotted line that goes right down negative 5. So if that's the case, I'm going to use that as my center for my table. And I'm going to find negative 6, negative 7, and negative 4, and negative 3. I'm going to find some of the points that are around there. When I did that, I was able to create this parabola. So we can see how it all develops. If I look at this, one of my y-intercepts and my other y-intercepts, x is equal to negative 6 and x is equal to negative 4. That is how our y-intercepts are related to our actual equation, and that's how our graph is related to our solutions. So it's exactly as predicted. X is equal to negative 4 and x is equal to negative 6 are zeros. They are roots. They are solutions. They are the x-intercepts of my graph. So we need to now be able to solve a couple of equations without a table or graph. We have one equation, 0 is equal to x minus 1 times 2x plus 6. Knowing that a number, or a parenthesis, times another set of parentheses, whatever's inside, if you multiply them together and they equal 0, one of those two things need to equal 0. So let's actually figure out what 0 is equal to x minus 1 would be equal to. Let's add 1 on each side. 1 is equal to x. There is one of my zeros. There's one of my roots. It's one of my solutions. This is an x-intercept of this particular graph. As well, we can say 0 is equal to 2x plus 6. We could subtract 6. From both sides, we get negative 6 is equal to 2x. Divide by 2, divide by 2. So we get negative 3 is equal to x. Here is my other x-intercept, or my other 0 for that equation. Now we have another one. 0 is equal to x squared minus 49. Simple enough, I suppose. There's no b, but at the same time, here's my c term, so I need to play around with that. I know 1 times 49 can get me 49, and 7 times 7 can get me 49. And I need to figure out what of these numbers will add or subtract to get me 0. Well, 1 plus 49 will get me 50, and 1 minus 49 will get me 48. So this is either 50 or 48, or potentially a negative or positive version of those. And then we have 7 plus 7 gets me 14, but 7 minus 7 gets me 0. So it looks like I have 7s. So we could say x plus 7 times x minus 7 is our factored form of this equation. So we're going to say 0 is equal to x plus 7 times x minus 7. From there, all we need to do is say x plus 7 is equal to 0, subtract 7 from both sides, and we get x is equal to negative 7. And we can only guess what the next one is going to be. If we have x minus 7 is equal to 0, I can add 7 to both sides, and I get x is equal to a positive 7. So these are my two roots, or my two solutions, my x-intercepts for this particular equation. Use this idea to go through investigation 3.4. This is completely within your wheelhouse. Play around with it. Find the x-intercepts. And note also that I do have another video dealing with this exact concept in the algebra playlist folder as well, if you want to look at that and have a little bit more practice. I hope this helps, and I will talk to you later. Thanks so much.